All right, Algebra 1, welcome to your application video, and I'm going to be telling you a little bit about how to use your calculator to help you graph exponential functions even better. So the essential question for today is, how can I use my calculator's table button to help determine values in an exponential function? Like I said, though, we're going to be applying this to certain situations. There are situations in life that require exponential growth and decay, and specifically this happens a lot with money. And whenever we're dealing with exponential growth and decay, we use a very specific model. It's called the growth model, and we can also make it into a decay model depending on some things, and we'll see what that is. I just need to tell you what each of these different letters means in our growth model. So first of all, we see this fact that we're multiplying an a times like a base of an exponent, and the a still means what it did when we graphed the exponentials in class on Monday and Tuesday. The a has to do with the y-intercept. In a real-life context, this means the initial value. So that a means the initial value. The way it shows up on the graph is the y-intercept. The r refers to the growth rate. So this is the rate at which something is growing. Typically, it'll be in terms of a percent, so you need to convert it to a decimal by moving the decimal 2 places over. Hopefully you remember that. Finally, the t is our variable here. This just represents time. Typically, the time is in years. So that's our variable. Okay, so let's look at question 1. You buy a government bond that gains 4% interest each year. So government bonds are these things. You can buy them from the government. Basically, the government is saying, hey, give us some money now, and we'll give you more money later on. This government bond gains 4% each year. So that's really nice. You buy it, and the government will just pay you back more later on. You're making money without really doing much. You buy this bond for $500. And we want to know how much will the bond be worth in 7 years, and also how many years will it take for the bond to double. So first of all, we need to set up our growth model. So we need to plug some different numbers into the variables. So let's identify. We need to identify what our initial value is. We also need to identify what our rate is. And it's really obvious in this case. It is 4%. This is the rate. So when I'm doing it in the formula, I'm going to put it as a decimal. 4% as a decimal means 0.04. I moved the decimal over 2 places. Since I've bought this bond for $500, this is our A. This is the initial amount, right? So now I have the equation. It's y equals 500 times 1 plus 0.04. And I'm going to keep the t in there. Remember, the t is my variable. My bond will be worth different amounts depending on how much time I have gone. We can simplify this just a little. I could actually add, let's do 500 times 1 plus 0.04 is 1.04. Obviously, right? And look, this looks very much like a function that we graphed before. Notice that the base of the exponent is bigger than 1, which means that this really will be exponential growth. And notice that the y-intercept, or the initial value, is 500. Now, what we did before is we plugged different values in for t, and we kind of did it by hand. But your calculator can actually do this for you, and I'm going to show you how. So go into your y equals menu, and let's just plug in the function. We have 500 times 1.04 to the power of, instead of t, we'll say x, because yeah, it means the same thing. X will be time in this case. Now we could graph this, but because of the super high y-intercept value, we would have to adjust the window a lot. So instead of graphing, let's hit second table. Notice that above the graph there's this little blue table, and look at what I have. I actually have different x values, and then it shows me the corresponding y values. And this is really nice because this is what we had been doing by hand before, but now you know how to get it using your calculator. It does the table for you. I can arrow up and down. I can also hit there's this thing called table set over above the window. So if I hit second table set, I can tell it like, hey, start the table at 50. And now when I hit table, it'll be up here at 50 rather than arrowing all over the place. So anyway, now that we know how to use table, we need to actually answer the questions. I'll start it at 0 again, and we can answer some of the questions. First of all, how much will the bond be worth in 7 years? Well, all I have to do is look at the table, right? I can scroll down. The table tells me, hey, if I plug in an X of 7 years, I will have $657.97. Very nifty. What your calculator just did for you is it took 500 times 1.04 to the power of 7, plugging 7 in for the t, and gave you this value. You could totally do this on your own using your calculator, or you can just have the calculator do it in the table. Next, it asks how many years will it take for the bond to double? Well, let's see. If the bond starts out at $500, I guess for the bond to have doubled, I'm looking for where it is $1,000. And this would be pretty hard to find if we weren't using the table. There's actually a really specific algebraic technique that we don't know about yet. But let's just look in the table for where the y passes 1,000. So I'm scrolling down. Y's are getting bigger, and oh, it looks like at year 17, I'm at $973, but now at year 18, I have passed $1,000. So how long will it take the bond to double? That would be 18 years. Very nice. And it's as easy as that if you have the table. So let's look at the next one. This is going to be a decay one, and we'll see why. You buy a car. That's exciting. The issue with buying a car is that as soon as you buy it, it starts losing value and fast. That's why cars are terrible investments. They make you look cool, but they lose value like crazy. So you buy a car that loses value at a rate of 15% each year. That means instead of my R being 0.15, actually my R is going to be negative 0.15 because I'm losing value at that rate. I buy the car for $8,000. Obviously, this is our initial value of A. And they're asking how much will the car be worth in 5 years? How long will it take for the car to only be worth $2,000? Well, of course, what we need to start with is we need to start by making our growth model, except now it's actually going to be a decay model, and here's why. When we do y equals, let's see, my A is now 8,000. Look, instead of 1 plus 0.15, I'm doing 1 plus negative 0.15, or 1 minus 0.5 to the t. So when I simplify this, I have 8,000 times 0.85 to the t. And look, this base of my exponent is less than 1. We said when the base is less than 1, it will be decay. So let's go ahead and update my calculator. Now my function is 8,000 times 0.85 to the power of, and again, I'm using x here as my variable. Again, I'll hit second table rather than graphing it. And let's start at 0. We can see at 0, yes, the car starts out at $8,000. And look, now it is losing money. After 5 years, because that's our first question, how much will it be worth in 5 years? It is going to be worth, looks like, $3,549.6. It has lost a ton of value. It was originally $800. Now it's under half of its original value. Not good for your car. Might not want to sell that. Might want to use it forever. Notice that this is exactly what you would have got had you replaced the t with 5 and just entered this into your calculator, just like you've been doing by hand all the other times. Also, they're asking how long will it take the car to only be worth $2,000. So we need to keep scrolling down in the table menu. Again, there's a very specific algebraic way that you can do this, but you won't learn that until Algebra 2. Okay, so it looks like in year 8, it was above 2,000. In year 9, it's below 2,000. This question is a little bit ambiguous. Let's say that after year 9, it will be worth under $2,000. I need to phrase it better on a test. Maybe I'll say, what's the first year when it's under 2,000? But for now, the wording's good enough. In year 9, you will only have a car that's worth under $2,000. All right, guys, just a summary. Use this equation. The A, it represents the initial value. You know that's like the y-intercept. The R, this is your rate. And you can use the table on your calculator. Remember, it's right above the graph button in order to easily find things for you. Thanks for watching.